Welcome to you all in my YouTube channel Express Mathematics. In today's videos, I am going to explain you about the addition of two vectors and also the parallelogram law of vectors. Before starting, I want you to make sure that you please subscribe my channel if you have not already subscribed, so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. So last time I explained different types of vectors. Now I am explaining addition of two vectors. Let vector A equals to OA vector equals to A1 A2 and vector B equals to B1 B2 B two vectors. Then the sum of the vectors A and B denoted by A plus B is defined by, okay, so here two vectors, vector A equals to A1 A2 and B equals to B1 B2 are there, and we have to find the sum of these two vectors. And while adding these two vectors, we add just like that in addition of the order pairs. Okay, it's defined by vector A plus vector B equals to A1 A2 plus B1 B2. Okay, this first component is added with first component and second component is added with second component. Okay, like that way we add two vectors, A1 plus B1, A2 plus B2. In this way, addition of two vectors is carried out. And this addition of two vectors geometrical interpretation is cleared by the parallelogram law of vectors and also by the triangle law of vector addition. Now let's move to next part, that is the parallelogram law of vector addition. Parallelogram law of vector addition. Okay, so according to this, the parallelogram law of vector addition, if two adjacent sides of the parallelogram starting from the same point represents two vectors, then the resultant is represented by the diagonal starting from the same point. Okay, so let's look at the proof of this. It OA be one vector and OB another vector, and let us compute the parallelogram taking the magnitude of OA and magnitude of OB as the adjacent sides of the parallelogram. Okay, let's do the parallelogram OACB. with magnitudes of OA and OB as its adjacent sides. Now OACB is the parallelogram. Okay, here OA is parallel to BC and OB is parallel to AC. And here this OA vector is A1, A2, and OB vector is B1, B2. Okay, and from A and AB and C, let's draw AP perpendicular to x-axis. From C, this let's draw CR perpendicular to x-axis, and from B, let's draw BQ perpendicular to x-axis. From A, B, and C, let us draw AP, BQ, and CR perpendicular to x-axis. And also from A and C, let's draw AS and CM perpendicular to CR and OI respectively. Okay, the CR is perpendicular to x-axis and CM is perpendicular to y-axis. Okay, so that means here this is also perpendicular, S is perpendicular to CR, and the CR is perpendicular to x-axis, AP is perpendicular to x-axis, BQ is perpendicular to x-axis, the CM is perpendicular to x-axis. And now here this OB is B1, B2 means this B coordinate is B1, B2. Okay, coordinate of B is B1, B2. So this OQ is B1 step right. And then BQ is, this QB is B2. Okay, this B point is B1 step right and B2 step up because its coordinate is B1, B2. That is vector OB is B1, B2, meaning it's OQ is B1 and QB is B2. Similarly, this coordinate of A is A1, A2. That means vector OA is A1, A2. This means this OP is, this is A1, and then this AP is, it is A2. This is A2. Okay. So not to make this proof lengthy, I am not writing the explanation of all these things what I have done. I have explained with the help of the figure. Here OQ is B1, QB is B2 because its coordinate is B1, B2, its coordinate is A1, A2. So this OP is A1 and then PA is A2. Okay. And now in triangles, CAS and BOQ in these two triangles, angle CSA equals to angle this CSA equals to angle BQO, because AS is perpendicular to CR, AS is perpendicular to CR, and BQ is perpendicular to OX. So as this AS is perpendicular to CR, CSA is 90 degree, and BQ is perpendicular to OX, so BQA is 90 degree. So both are right angles, so they are equal. Okay, both being right angles. And for this we can also write R here. Okay, and this both are right angles, so for right angle R is written here. And in these two triangles here, AC equals to we can write OB here, being opposite sides of the parallelogram, being opposite sides of parallelogram OACB. Okay, so opposite sides of the parallelogram are equal, so AC equals to CB. Okay, these two sides are equal. And here in bracket we can write S for hypotenuse, because as this angle is 90 degree, so opposite of this 90 degree, AC and OB, these are the hypotenuse of the right angle triangle. So S we can write for this. And next to that we can write here CS equals to BQ, being heights of parallelogram, same parallelogram. Okay, same parallelogram OA CB. Okay, so heights of the parallelogram measured anywhere, they will be same. Okay, so CQ equals to CS equals to BQ we can write. So for this we can write side. Okay, therefore triangle CAS is congruent to triangle BOQ by right hypotenuse side principle. Okay, by this principle, these two triangles are congruent by right hypotenuse side principle. They are congruent. Okay, now any vector, let us join this OC. Okay. Let us join OC, and any vector is given by projection of that vector on x-axis and projection of vector on y-axis. Okay, so projection of that vector on x-axis gives x component of that vector, and projection of that vector on y-axis gives the y component of the vector. Now x component of vector OC equals to your x component of vector OC, or projection of vector OC is given by the equals to projection of OC on x-axis. Okay, so x component of vector OC is given by projection of OC on x-axis, and projection of OC on x-axis is here, that is OR. This projection of OC on x-axis is OR. Okay, and this OR is equal to OP plus PR. Okay, this OR equals to OP plus PR, as you can see clearly from the figure. And this OP is A1 plus this PR is equals to AS. Okay, because this angle is 90 degree, this is also 90 degree, this is also 90 degree. So this APRS is the rectangle, so opposite sides, this PR and AS are equal. So OP is A1 and PR is equals to AS, and this AS is also equal to OQ. Okay, A1 plus OQ, because this AS and OQ, they are the corresponding sides of congruent triangles CAS and BOQ. Okay, this CAS and BOQ already proved that congruent triangles. So this side is equal to this side is equal to this one, and this remaining sides AS and OQ are also equal. And now this equals to A1 plus OQ is, from here it is B1. That means x component of OC means projection of OC on x-axis, that is A1 plus B1. And next to that is the y component of OC is equals to, that is given by the projection of OC on y axis. Okay, projection of this OC on y axis gives the y component of vector OC, and projection of OC on y axis is given by OM. Okay, this OM is the projection of OC on y axis. Actually, projection means that from both part of the line segment, if you draw perpendicular, then the line segment joining the foot of the perpendicular gives the projection of that line segment. And here OM equals to, here also this is 90, this is 90, and this is also 90. So this ORCM is the rectangle, so OM equals to RC. Opposite sides of the rectangle are equal, and this RC can also be written as this RC equals to RS plus SC. Okay, and here RS is equals to AP, that is equals to AP plus here SC is equals to QB, because this SC is the height of the parallelogram, QB is also height of the parallelogram. Okay, already we have shown it. So height of the parallelogram are equal, and this equals to AP. AP from here is A2 plus QB. QB from here is B2. Okay, in this way we have got y component of vector OC equals to A2 plus B2. Therefore, any vector is completely written by taking its x component and y component. If it is the plane vector, okay, it is if the vector is in two-dimensional plane, and therefore vector OC equals to we can write projection of OC on x-axis, that is OR, projection of OC on y-axis is OM, and that equals to here OR is A1 plus B1 and OM is A2 plus B2. Okay, and you can call this as equation 1. Also OA plus OB equals to OA is A1 A2 plus OB is B1 B2. OA is A1 A2 plus OB is B1 B2. This equals to A1 plus B1 A2 plus B2 by the rule of addition of vectors. Okay, so let us this to be equation 2 here by the rule of addition of vectors. We can write this now from equations 1 and 2. From equations 1 and 2, what we can write is we have OA vector plus OB vector equals to OC vector. Okay, and in this way it's clear that if two adjacent sides OA and OB starting from the same point, okay, so from this it's clear that if two adjacent sides OA and OB starting from the same point represents two vectors in magnitude direction, then the resultant is given by the diagonal OC of the parallelogram starting from the same point. Okay, this is the parallelogram law of vector. So from this result we can conclude that the sum of the vectors OA and OB is represented by vector OC, which is the resultant, which is the diagonal of the parallelogram having the magnitudes of OA and OB as its adjacent sides. Okay, from this result we can conclude that the sum of the vectors OA and OB is represented by OC, which is the diagonal of the parallelogram having the magnitudes of OA and OB as its adjacent sides. Okay, in this way if two vectors represents two adjacent sides of the parallelogram starting from the same point. Then the resultant is given by the diagonal starting from the diagonal of the parallelogram starting from the same point in magnitude and direction. Okay, this is the proof of the parallelogram law of vectors. I hope that you found this video helpful. Thank you for watching, and if you have not already subscribed my channel, please subscribe it right now so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. Thank you very much.